Good morning, everyone. So today I want to talk about spatially resolved observations of outflows in the radial AGN of UGC 872. So my name is Gabriel da Souza Oliveira. I'm a PhD student in the astrophysics group in UFSM, and my supervisor is Gemini North. So the main question that our field are trying to answer is how the active galactic nuclei are important to the evolution of galaxies. So we don't know how much of the active in galactic nuclei are important to the star formation, for the structure of galaxies. So that's our main question. The set of possible phenomena that can occur in a galaxy that can change how the galaxy forms related to the activity of the galactic nuclei are called feedback. And one type of feedback that we study is outflows, that are ejection or redistribution of gas inside the galaxy or outside the galaxy. The mechanisms that generate outflows are not well understood yet, and either all the characteristics of its phases. So outflows can be hot, can be cold, can be warm. There are outflows that are ionized from ionized gas. There are outflows that are related to molecular gas. So we don't know all the phases that outflows can present. So next, the motivation for our study with these galaxies. So our goal is to study the molecular phase of outflows, mainly due to its mass. So the molecular gas is more massive, and they have the sufficient power or enough power to quenching the star formation more than the atomic or the ionized gas, just because its own mass. We have information about the cold phase, temperature less than 100 Kelvin. We have information also about hot gas that are above 1000 Kelvin. But we don't have a lot of information about warm gas. So that's our goal when we are studying this galaxy. From this work, from HIFO, using Spitzer telescope data, we discovered that there is a correlation between the dispersion velocity of the O1 emission and the emission of a molecular gas, A2, this specific line, X3. And that's why we are studying this galaxy. We are not studying in this specific paper the infrared data from this galaxy, the spatial information. This paper was idealized to complement the characterization of the emission of this galaxy in the optical wavelengths. So we have a proposal with the GWST related to this galaxy. So we are actually preparing our studies to this incoming data that we will observe. So observations and data reduction. We use the GMOS, the Gemini North multi-object spectrograph, operating in the integral field unit. So here we have the Gemini North telescope. Here are the GMOS. There are like a box that are plugged in the focal plane of the telescope. So the reduction, that is an analogous of cleaning of the data, was made using IRF software. That is a famous software that are used for basic all astronomers, and to remove the cosmic rays that can appear on our observations, were used use Laplace algorithm. So cosmic rays, we observe them in spectra like a huge spike. So when we compare with other line emissions we see that they're different, and we have to remove. Okay. So next, measurements and results. So here we have, like I shown in the last seminar, using the IFSQ package, we analyze this galaxy. Here, the first three columns are the narrow component. We model the gas kinematics of this galaxy with two Gaussian components. So here we have the disk component that tends to follow the movement of the stars in the galaxy, and here we have the columns related to the broad component. So the components of the outflows. Clearly, we can see all these blue blocks here. That's these are the outflows, how we can see them. So the color are showing to us that the gas is approaching, and all this gas is approaching towards us, escaping to the galaxy, or at least ejected from the disk. Okay. Here we have the PPT and one diagrams. These diagrams are used to characterize the emission, the origin of the emission of the gas. So from these maps, we can see that basically all the emissions are due to the AGN. So this red area here is due to the AGN source. And we also discover that the emission of the O1 line also are due to shocks or gas collision. So when actually we can correlate the sigma, the dispersion of the velocities of the broad component, to the flux ratios of the O1 line emission. And so this map here that we are seeing are not just due to the AGN emission, but also to shock ionization related to the radial emission that are present in the galaxy, these contours, green contours here. What else? So, as results, the gas kinematics is all described using two Gaussian components. The emitting gas presents high velocity dispersions around 500 kilometers per second. There are this relation here, spatially with the emission outflow 1, so we can conclude that our probably jet cloud interaction with the radial jet. The narrow component is describing well the rotating disk pattern. The broad component is blue-shifted by 150 to 500 kilometers per second. This broad component blue-shifted is what I was talking, this max here. And we estimate the mass outflows, rate, and kinetic power of the ionized gas outflows at different distance from the nucleus. We do that to quantify how the nuclei, the active nuclei, are affecting their surroundings. And what we found that is the kinetic power of the outflows correspond to 1 to 3% of the AGN volumetric luminosity. There is some criteria to what we consider that the active nuclei are or are not influence their surrounds, but I think around 0.5% to the 5% are the beginning of the criteria, beginning of consideration actually, to characterize as an AGN capable to affect star formation or the surroundings of the active nuclei. These are actually yet in debate. So when we look just for the optical part of gas emission, and we already can estimate that we have an outflow with net power of 1 to 3%. We also can expect that other phases of the gas can have more power to stop star formation or change the structure of the galaxy. So this is indicative just for this phase. We are preparing to study other phases and see how the AGN alter the medium of the galaxy. That's it.